Okay, so for the second synthesis example, I'm going to go to the text and show you the first section that this shows up. So recall, please, that chapter 1 was basically principles of chemistry, chapter 2 was acids, chapter 3 was structures, chapter 4 was more on structures like cyclohexanes. It wasn't until chapter 5 that we actually got into reactions. And so in reactions, we talked, in chapter 5, we talked about alkenes. And at the very end of chapter 5, we started talking about the reactions of alkenes. Right? So we're in chapter 6 now. And this is the first chapter where we get really a bunch of reactions. And so it's time, as you might imagine, this was additions to alkenes, right? So chapter 5 was alkenes. Chapter 6 was the reactions of alkenes. So we finally got a lot of reactions. And it's time to introduce the concept of reactions and synthesis, right? What are we going to use these reactions for? So yeah, don't be overwhelmed by this. You know, the next chapter is probably going to be alkynes, right? Triple bonds, which comes after double bonds. And then the next chapter is going to be, you know, another functional group, and then another functional group, and then another functional group. Pretty soon we're going to be in the groove, where we have one chapter that's dedicated to each functional group or some sort of class of functional groups. And we're always going to be asking ourselves, what can we do with these reactions? And so at the end of most of these chapters, there's going to be a section on synthesis. All right? So in the past video, I just made up a synthesis problem sort of on the spot. But let's go here and show sort of from Bruce's standpoint what she means by reactions and synthesis. So it's, I think, good. This is really a summary of the entire chapter. Okay, you can take a double bond and you can add bromine to it. You can add HBr to it. You can add water to it, right? You can add water to it a different way. You can make an ether. You can cut it with ozonolysis, right? You can make an epoxide. You can get rid of the functional group, or you can make a halohydrin. There's a lot of things you can do with that. That's a lot of stuff for one chapter. That said, be encouraged. A lot of the mechanisms that we have for this are sort of map over onto each other. These two are very, very similar, right? That's not similar to those. This is sort of similar in that it's like an intermediate of that. This was pretty different. And these three were all, I guess, more like that. Okay? So that's what we're going to be doing here. So let's take a question that she asks in this chapter, and let's do a synthesis problem for each of these. So, again, just to sort of, you know, just to sort of frame it a little bit better than we framed our last problem. Show how each of the compounds can be synthesized from an alkene. Right, so we look at that. Let's take C. I'm arbitrarily choosing C. Example 2. And we're asked, show how this stuff can be synthesized from an alkene. All right, well, we know that we have a reaction of how we can make, right? We had that reaction in our head. This was called hydration. I don't remember where it is in the book, but it's somewhere in chapter 6. Chapter 6? Okay, we had two ways to make that. Oh, well, I'm sorry, we have two reactions here. One of them, though, is this reaction, right, which gives us the Markovnikov addition, and the other one was this reaction, which gives us the anti-Markovnikov addition, right? So we've got to choose which one of these we want, and from there we can make our reaction, right? This one goes to this one's the Markovnikov, which will substitute on the more substituted carbon because of the transition, or because of the intermediate. And this one will go to the less substituted carbon. And which was which? This was simply acid, which I think we used H2SO4, and water, H2O. And this was BH3. That was one form of the reaction that we did, THF, with and chased it, right, with hydroxide, hydrogen peroxide, and water. And which one of those do we want for this reaction here? Right, it's definitely going to the outside one. So what we need then is that, and we need the hydroboration. How do you spell boration? Okay, that's the one we want for that. All right, so what I want to demonstrate with this, I want to demonstrate not the answer. I guess going back to Bloom's taxonomy, right? I want to show that I don't want just an answer. I mean, I guess in this case there might not be another answer in the case of this particular problem, but we need to be able to be thinking of for analysis, evaluation, and creation. We need to be able to think, how are we going to get there? If we have this question here, what kind of things do we have to think about? And that's what I'm trying to demonstrate with this video.